Pues se ha empeorado porque a veces no llueve. Llueve poco, tarda 8 días, 15 días, no llueve.
The Yucatan Peninsula contains extensive rural landscapes where many communities continue to live and farm outside of major urban centers. Across these rural areas, small-scale agriculture remains closely tied to environmental conditions. In much of the peninsula, milpa agriculture remains largely rain-fed, with little to no supplemental irrigation. In recent decades, the midsummer drought known as canicula has increased both in intensity and variability due to rising temperatures. Despite these conditions, atmospheric moisture remains abundant across the region, with an average relative humidity around 74%. This creates a paradox in which water is abundant in the air while soil remains dry. If water remains consistently present in the atmosphere, how can it be harvested and converted into usable water for small-scale farmers across the region?
An approach was developed using hygroscopic materials, which have an inherent ability to absorb atmospheric moisture. An experimental material was developed using sargassum from the shores near Cecil, seaweed that repeatedly washes ashore, creating ongoing ecological challenges for the region. The seaweed was combined with calcium chloride to create a biochar to be tested in this experiment. 2 additional locally sourced hygroscopic materials were gathered to be tested alongside the sargassum. The device is organized around a vertical cylindrical form that is placed directly into the ground. This orientation allows any collected water to be delivered passively into the root zone without the need for surface storage or redistribution. At the center of the device is a perforated internal chamber designed to expose the hygroscopic material to as much airflow as possible. During humid, nighttime conditions, a ventilated cap is placed to promote airflow through the chamber, allowing the material to absorb atmospheric moisture when relative humidity is the highest. At the start of the day, the fan cap is removed and replaced with an airtight solar lid. The transparent solar shield on the front directly faces the sun, allowing the device to heat up under direct radiation. As internal temperatures rise, the stored moisture is evaporated from the material as a vapor. This vapor condenses along the interior surfaces of the enclosure and is guided by gravity directly back into the surrounding soil.
¿Cuándo volverá el agua?
Yeah.
Hasta el mes de junio.